We're going to continue off of the problem that we were doing in the first part of the Z interval. And that's, suppose a company is wondering what's the mean commute time for their employees. Because after all, if you've got good professionals, but they're spending over 100 minutes a day commuting to and from work, then maybe you could have a policy where 2 days a week the employees stayed home. That would save them over 3 hours a week in commuting time. And you'd expect them to get a certain number of things done, but you hope their creativity, their energy is stronger, and morale is increased. So there's some give and take. There's some benefits to some companies doing that, to saying, hey, let's make your lives a little bit more easier. Instead of wasting your time with the commute, let's keep you fresh and let's have you be creative and come up with some good ideas. So if we're going to do a confidence interval, we're going to estimate a parameter with a certain level of confidence. So we're going to say we want to figure out what that guy is. Are we going to do it with 95% confidence? Whatever. Let's say we're going to do a 94% confidence interval for a population mean. Then here's how this works. We could use our inverse normal function and find the z-score, the plus or minus z-score, that would trap the middle 94%. If we were going to trap 94% in the middle, keep in mind that that would imply that we would trap 3% on the tail. And if you do inverse normal on 0.03 with a mean of 0 and a standard deviation of 1, we find that this is the z-score. Now what this means is, in 94% of all samples taken, the sample mean would be within 1.88 standard deviations of the true mean. So again, whatever our sample mean is, we can add this margin of error to the right or left, and we should be trapping the true mean in that interval. You can see the first part of the video. Here's the formula when it comes to AP statistics and constructing a confidence interval. If we're trying to estimate a population mean, mu, then its statistic is the sample mean, x bar, plus or minus a critical z-score based on how many standard deviations you travel to trap the desired percent or the desired confidence, times the standard deviation of the statistic, and we know that the standard deviation of sample means would be that puppy right there. So this is the work we have to show. We would take our sample mean of 108.2, we'd go plus or minus the 1.88 standard deviations that we need if we're going to be 94% confident to trap the mean. And we're going to multiply this by the standard deviation divided by the square root of the sample size, and we know that to be 7. So we're going to end up showing our work like this on our paper, but then we're going to actually do that confidence interval on our calculator. We'll see that in a minute. So that's the big idea. That's how we follow the formula. So these are the 4 steps that we're basically going to make. Different people have a different combination of words. Some have nice acronyms. That's all I got for you right there. So step number 1, we're going to name the interval and the parameter. Well, we're going to be doing a 94% Z interval, just like the Z test. We're going to use a Z interval. Clearly that is a Z. Okay, on the parameter, which would be the mean daily commute of our employees. So that's naming the interval, and that's naming the parameter. So that's step 1. So that's done. Then we go to step 2. We need to address the assumptions. And this again is that the data had to come from a random sample. The sampling distribution had to be normal, and this can happen as long as our sample size is at least 30, or if the probability distribution was normal to begin with. And then just like with the Z test, sigma had to be given to us, and we have to address those things. So let's suppose the problem, it did say we took a random sample of what was it, 36. So we would say SRS, we were told it was random. That was good enough. Our sample size was 36, so it was at least 30, so we know our sampling distribution of means is normal, and we were given the standard deviation. It was given to us as 42 minutes. So that's the end of step 2. If you're not comfortable with that, you need to go back and look at the video on just the Z test of means, because it's the exact same information in regards to addressing the assumptions. Showing your work. This is where we say, oh, okay, we take the sample mean plus or minus the critical z-score, which we could use inverse normal to do that, and then multiply this by the standard deviation, which was 42 over radical 36. And then we're not really going to crank this thing out. We're not really going to take the time to do that by hand. What you can do is you can even tell the reader, hey, I'm going to my calculator, and we're going to let the calculator calculate the confidence interval. So we're going back to stat. We're going over to tests. And this time we're going to 7. It's a Z interval. We've shown all the work we really need to see. Let's let the calculator do its thing. We have the stats. We type in the standard deviation of 42. We type in the sample mean we got, which was 108.2 minutes per day. We type in the 42 is our sample size, and then our confidence level needs to be, we're doing a 94% confidence interval, so we're going to do 0.94. That's going to be our confidence level. Then we go down and we hit calculate, and voila, it will give us our interval. So we've shown the work. We're going to go ahead and say the calculator returns to us an interval from 96.01 to 120.39. Okay, now we know that those are in minutes. But at any rate, here's our final thing. We're going to say, okay, now we have to correctly interpret the confidence interval. So we're going to go over here and we're going to say, okay, let's correctly interpret what this means. And we will say that we are, in this case, 94% confident that, and now we have to describe the parameter that we're estimating, that the, I like to say true mean, but we could just say mean, that the true mean commuting time for these employees is between about 96 minutes and 120.4 minutes. There you go. That's the write-up, those 4 steps. So that's what we'll be doing, and then we'll get more and more complicated, more and more sophisticated with how might we perhaps use a confidence interval to know what the result would be in a hypothesis test without actually running the test. So again, the most important thing is understand the concepts as well as possible. It's good that we can do the steps, but we need to know what it is we're doing and why we're doing it all along the way. Ask questions, watch videos, do what you got to do. The more we understand, the more powerful we are, and the more proficient we'll be at statistics and knowing what we know and what we don't know.